Hi, I'm Guo I'm 15 years old, secondary 3 for NS High School. In this lesson, we're continuing with physical chemistry. So, what did we have in the last lesson of physical chemistry? Now, if we were to look at the board over here, last lesson we had part of the Maxwell-Boltzmann velocity distribution. So, on top we have our assumptions, and below we have the first few parts where we can separate FV, which is our probability density function. So this probability density function, you can split them into these three different components as Vx, Vy, and Vz are independent of each other. So then you can factorize, and using these two separate ways, which one you use the part behind, the other which you use total differentiation. So using those two ways, you find out what each are. You manipulate the first part a little bit and substitute them into one another. And at last, you have a form like this, which afterwards you would divide all of these terms by, again, your probability density function, and you let that be a constant. So afterwards you change it, or you take it as an ordinary differential equation, which is separable. So manipulate a little bit and you have this part over here, which then you have to let your power be negative, as you need to be able to solve it, since you have the convergence and divergence, and it is only solvable when the power is negative. So afterwards you find the entire probability, since your density, you have all of them added together, which at last you have 1. So after you get that part, you have your constant in front here. So after you get a constant, you just sub it back and you get a form similar to your Maxwell-Boltzmann velocity distribution. But of course, another problem is the A, that we haven't solved it yet. But that we would solve it in the future eventually, alright? But now what would be our focus in this lesson? So in this lesson, if you have already heard of something called like your highest speed, or your means of your velocities, or even your root mean square. So those will be the three things that we will be looking at for this lesson. So let's recall what we had from the previous lesson, which is Fv is equal to square root a over 2 pi cube multiplied by e to the power of negative, so you're going to have av square over 2. Right, well here a is equal to m over your Boltzmann constant multiplied by T, and T is the temperature in Kelvin. Right, so this is what we have from the previous lesson. And again, if you really want to find out how you get A, you have to wait for future lessons. Alright, so in this lesson, what we'll be mainly focusing on is the most probable speed, your average speed or mean speed, whatever you like to call it, and your root mean square speed. Right, so before we start, are there any modifications that we would like to make to our original function that we have over here? So when you think about trying to find your different types of speeds, you might want to consider, since this is 3-dimensional, you might want to consider spherical coordinates, since it will be the same from every direction, if you can see that. So now how are we going to change this into spherical coordinates? Well, firstly, let's start off with just a probability, right? So how are we going to have this probability? So you're going to have 4 pi v square, and then square root a over 2 pi cube, and here e to the power negative av square over 2 and dv. So if you have no idea how 4 pi v square came from, 4 pi v square is just the surface area of your sphere, or you can also think about it as just a shell, alright? So you might be kind of confused. V, a velocity. Well, here you're just taking it like your x, y, and z when you're doing Cartesian, right? Which you can also think of it as your radius, right? So this is what we are going to see for a probability. So how about let's change that back into our probability density function. So that we are going to see Fv. So you can still keep it as 4 pi v square root a over 2 pi cube e to the power negative av square over 2. Or if you can see it, you can also combine these two parts where you have pi and divided by pi, 4 and divided by 2 to the power of 3 over 2. So what you are going to see, so a, you don't have it anywhere, so that means you're still going to have a cube inside your square root. So 4, which is just 2 to the power of 4 over 2 minus 3 over 2, which you just have 2, and here you have over, so pi is just to the power of 2 over 2, which is just over pi. Alright, so then you're going to have v square e to the power negative av square over 2. So again, you might be wondering, how are we going to use this to find the most probable speed? Now, think about differentiation. If you're given a graph, y is equal to some function of x, how are we going to find those different, let's say the highest, since the most probable speed is essentially your mode if you learn statistics, since you have 3 different types of means or averages. So this is essentially finding the mode, which when you have the highest in the graph, the gradient is actually a straight line, and the gradient is just 0, right? The tangent is a straight line, I mean, and the tangent has a gradient of 0. And how do you find the gradient? Well, that's differentiation. So that means we're going to differentiate this function over here and make it equal to 0. So how are we going to achieve this? So dfv dv. So this here is going to be, you have to be aware of a product rule that you're going to have to use, which you will see 2 square root 2a cubed over pi. Of course, you can put this 2 inside with the v, since it comes from the v square, but it's really up to you. Then you have e to the power of negative av square over 2. So next, you have your product rule, and then you have to be aware of a chain rule. So at first it is a plus, but since chain rule, you have a negative in the power, that means you have to minus. So minus in the power, you're going to see a. So a square root 2a cubed over pi v square e to the power of negative a v square over 2. But again, chain rule, so you're going to have v cubed. Alright? So is this clear of what you're going to see after you differentiate it? Alright. So let's factorize the parts that look similar. You have square root 2a cubed over pi, which is present in both. You have v, which is present in both, and you have the entire e to the power, which is present in both. So which parts are not present in both? You're going to have 2 from here, and a v squared here. And then the rest is your square root 2a cubed over pi and e to the power negative ab squared over 2. So this is supposed to be equal to 0. So if you want here being equal to 0, that means in front you have to use let. Alright, so this is what we are going to see. Now how are we going to determine what are the values of v? Whoops, and there's another v here. Alright, so of course the easiest one to find is v equal to 0. So yes, v can be equal to 0. But is there any others? Here is just a coefficient that you can't do anything about it. So from this part, if you let this be equal to 0, which is 2 minus av squared is equal to 0, that means 2 is equal to av squared. And doing a little bit of shuffling around, you're going to have v squared is equal to a over 2. So v is equal to square root, 2 over a, so square root 2 over a. And a, you put this back here, and you're going to see square root 2 Boltzmann constant times your temperature over m. So this is another v that we're going to see. Now look at your exponential function. Is it possible to get a 0 from there? Does it seem possible? Well, it doesn't really. So this part we can't really do anything about it. Right, so these would be the two solutions. But which one would be more preferred if you think about it? Well, of course, v2 would be more preferred, since if you just have 0 for everything, then it's not going to be much. So that means v2 is going to be our most probable speed. So you can put it as v most probable is equal to square root 2 kbt over m. Alright, so now we have completed the first part, which is to find our most probable speed. Now the second part is to find our average speed. Now the average of the entire thing, how are we supposed to find it? So now if you know a little bit of statistics and expectations, so what you are going to see would be, you are going to have, well, of course here you can just put v bar. It's a way of representing it. So 4 pi, and since if you know a little bit of expectation, you have v cube. Alright, so of course you can use from this part or you can use from this part, which then in that case would just be, let me just change it in another form. So what else are we supposed to do for this part? It means we need integration, since we need to find the average. That means it is for every single value inside the entire range that we are going to have. And speed, it is 0 to infinity, since we aren't going to really think about negative speed here. And of course the v. Alright, first things first, you would want to take your coefficients out. So you're going to see square root 2a cubed over pi outside here. And inside, you could put one of the v inside. Now you might be wondering, what does that do? It just, you have a half outside, so 0 to infinity, v squared this time, e to the power negative av squared over 2, and you're going to have dv squared. Alright, so what does this do? Now what if we make this part the same as your power in your exponential function? Now if you have done before like more complicated integration functions, this might be obvious, might not be obvious. It depends on what kind of experience you have. So when we put this in here, what are we going to have? That means we're going to have a negative 2 over a. So integrate from 0 to infinity v square d e to the power of negative, or if you want to wait a little to see if you can find it, it will be e to the power of av square over 2, and d, this will be negative av square over 2. Alright, which really you can just put your exponential function inside. Alright, so how do we proceed from here, you might be wondering. So negative, that means we could combine this part again, and you have square root 2a over pi, which integrates from 0 to infinity. So I'm just going to write out the part where you put your e inside, so e to the power negative av square over 2. And if you know integral by parts, this is where we use something called integral by parts. So how do we use integral by parts here? We are just going to have, I'm just going to write this below, right? So integral by parts, we're going to see negative square root 2a over pi. And the first part, u dv, which is u v, and you're going to have v square e to the power of negative av square over 2. And this here, you need to substitute 0 and infinity. So for your other parts, which you're going to have plus square root 2a over pi, you are going to see integrate from 0 to infinity e to the power of negative av square over 2 dv square. Alright, so since this is what you are going to see, now if you substitute the values in for your first part, you're just going to have 0 for your entire first term. So 0 and plus, which you don't really need to write. So then we can do the same again. Now what do I mean by the same? Of course you can change this into this form here. Alright, so you have square root 2a over pi, negative 2 over a. Integrate from 0 to infinity, well, e to the power of negative av square over 2 d negative av square over 2. So afterwards you can just immediately get that this part is e to the power of negative av square over 2. While in front here you're going to have negative square root 8 over a pi. Alright, since 2 you put this 2 inside and the a inside too. So e to the power of negative av square over 2, and this you have to sub 0 infinity. So when you substitute in infinity, you're just going to have a 0. So when you sub in 0, you're going to have a 1, which means there will be a negative and negative, which they cancel out and become a positive, and you would have square root 8 over a pi. But again, a, you could change it back into your m over Boltzmann constant times t, which will have 8 kbt over pi m. And this is your average speed, alright? So now we have our most probable speed, our average speed. We are just left with one more, which is our root mean square speed. So again, how do we find root mean square? As its name just states, we take the mean, we take the root of the mean of the squares. So how is that going to happen now? So all we are going to see is going to be, let's say we call this V RMS, root mean square. So the root mean square speed, we are going to have square root and integrate from 0 to infinity square root 2a cubed over pi v to the power of 4 this time, since root means square, e to the power of av square over 2 dv. Alright, so now this is what we just have to find. So we can try to reuse the same method, which from up here. So you're going to see square root 2a cubed over pi. So from this time times half integrate 0 to infinity, and you're going to have v cubed multiplied by e to the power of negative av square over 2 and dv square. So same thing, we put the entire exponential part inside. And this is what you're going to see for the coefficients. And then integrate from 0 to infinity v cubed d e to the power of negative av square over 2. So once again, we would be using your integral by parts, alright? So now this coefficient in front is negative square root 2a over pi, and integral by parts, you're going to have v cubed e to the power of negative av square over 2, 0 and infinity, then followed by plus square root 2a over pi, and you're going to see a swap in the 2, which is integrate from 0 to infinity e to the power of negative av square over 2, then d v cubed this time, right? So once again, the first term would become 0, so all you're going to have is now square root 2a over pi, and here you have 3, since you can take the v cubed out. So integrate from 0 to infinity, and you're going to have, since you take the v cubed out, you're going to have v square e to the power of negative av square over 2, and then dv. Alright, so this portion, once again, you are going to use your integral by parts. But of course, the integral by parts, first you will need to put a v inside. After you put the v inside, you're going to have the entire e go in. So this is a rather tedious process, I would say. So 3, you can choose to leave it outside or multiply it inside. So 3 2a over pi, and then times half. So 3 again on the outside, you're going to have square root a over 2 pi. Then integrate from 0 to infinity, but of course you would have another coefficient coming out in front, which I accidentally missed. So what is this coefficient in front? It would be your negative 2 over a. And this here, you're going to see integrate from 0 to infinity v d e to the power negative av square over 2. Alright, so this is what you're going to see. Now we are going to use the integral by parts. So square root, negative 3 again we leave on the outside. So square roots, you're going to have 2 over a pi. Then v e to the power negative av square over 2. You're going to have substitute 0, infinity, then you're going to see plus 3 square root 2 over a pi. So it is a swap of the two, which is integrate from 0 to infinity, and e to the power negative av square over 2 and dv. Now this is something we have seen in our last lesson, which what we have used is e to the power of negative x squared dx, and those, there are like around at least 2 ways, which 2 of them are, let's say, double integration and your gamma function. So those are just 2 of the ways you could solve it. If you have any other way, well, good for you. So from this portion, we can square root 3 square root 2 over a pi. So v, you're going to have square root, so since that's a over 2, so 2 over a, and integrate from 0 to infinity e to the power of negative av square over 2 d square root a over 2v. So this is where we have square root pi over 2. So 3, and we would see times, or you can put this 3 up there too, it doesn't matter much. So 3 times you'll have 2, and you're going to have a pi, a square root pi here, since 2 of the square root a's and 1 of the square root pi's, and over here it is square root pi over 2. Alright, so these portions will cancel out, and you actually have square root a over 3 over a, which would give you square root 3. So a, you start back that part again, and you have 3 Boltzmann constant times t over m. So these are the 3 parts that you're going to have, which from here, your most probable speed, from here your average speed, and from here your root mean square speed, which if you compare the 3 of them, your most probable speed is smaller than your average speed, which is smaller than your root mean square speed. So these are just the few values that we would get from what we have over here. So this is pretty much all we're going to have for this lesson, and I hope you can understand all of it. So just be aware again, A, we will determine in some other lesson, alright? So I hope you can understand everything for this lesson, and thank you for your watching.